So finally, in our final part for section 5.5, we'll show you why we do polynomial and rational inequalities in order to find the domain of some more complicated looking functions. That's why we do this. So let's find the domain of f of x is equal to the square root of x to the fourth minus 16. Well, back in chapter 3, we said that in order to find the domain of a radical function, you're going to take the inside and set it greater than or equal to 0, because you have to guarantee that the inside is positive in order to take a square root in a real number system. So that's telling us to take x to the fourth minus 16 and set it greater than or equal to 0. Well, sure enough, we're right back to what we were doing. It's a polynomial inequality. So I'm going to factor it. It factors into x squared minus 4 and x squared plus 4. And then the x squared minus 4 can factor again. So x plus 2, x minus 2, x squared plus 4 greater than or equal to 0. The x squared plus 4 is going to give me plus or minus 2i as zeros, and those don't impact the number line. So we're going to ignore that for now. In terms of boundary numbers, the only thing contributing is this first factor, gives us a -2. The second factor gives us a +2. And again, this gives me i's. It doesn't impact the graph. So you'll have your test value. You'll have your x plus 2. You're going to have your x minus 2. And you'll have your x squared plus 4. Now, I'll be honest, you don't really need to list this x squared plus 4. Can you tell me why you don't need to list that x squared plus 4? So no matter what x value you pick and plug in when you square it, it's going to be positive. Adding the 4 is still going to make it positive. That tells me, I mean, it's really saying that this graph, that the x squared plus 4 as a factor did not impact the graph because zeros were i's. That's why. Okay, to the left of -2, like -3, we're going to plug in, you get a negative and a negative. The net result is a positive. Between -2 and 2, we're going to plug in a 0. The first one's positive, the way I've got them listed. The next one's negative. The net result is a negative. Something larger than 2, like a +3. 3 plus 2 is positive. 3 minus 2 is positive. The net result is a positive. And at some point, you can start to speed that process up. Okay, according to the inequality, because we're looking for the domain, we need that inside to be positive. So we're going to pick our positive regions. So our domain is going to go from negative infinity to -2 and from 2 to infinity. And there's our domain. So pretty straight and very straightforward when you get to this part of it, because you've already done so many time charts to get used to it. So one more and we'll call it good for this section. So part B is asking us to find the domain of a rational function f of x is equal to the square root of x minus 2 over x plus 4. So again, to find the domain, I have to take what's on the inside, called the radicand, and set it greater than or equal to 0. So our boundary numbers are 2 and -4. -4 is a vertical asymptote. Test value, I have x minus 2 and x plus 4. And I have the result. Again, there's no multiplicities, no squares. I expect this to be fairly straightforward in terms of the end result. So make sure they're in numerical order when you list those boundary numbers. Never one mistake. Okay, to the left of -4, we can use -5. We'll get a negative and a negative. That one's positive. Between -4 and 2, we're going to use 0. That one's negative. This one's positive, and it results in negative. Larger than 2 is 3. 3 minus 2 is a positive. 3 plus 4 is a positive, and the net result is a positive. So again, I expect that alternating sign into results. Okay, according to the inequality, again, we're going to pick the positive regions. We're looking for the domain. So to answer the question, our domain is going to be these two regions. Now, don't forget the -4 was the vertical asymptote. So we're going to go from negative infinity to -4 with a parenthesis. You cannot include that vertical asymptote. Divide by 0. But we'll put a bracket on the 2 to infinity. And there's the domain of this rational function, rational radical function of this function. And that wraps up chapter 5 for us. So that's now the end of chapter 5. Only one more chapter to go, chapter 6. It does have a lot of information, but we're headed to 2 brand new functions for us.